Oh, I'm doing a scientific experiment here. Well, you would like to know what this here has to do with that? You don't know? Well, you have to say not yet. Stay tuned, I tell you. So, this here is in fact a process vessel. And if you would like to know what actually happens inside that process vessel, which is used for the enrichment of a carrier gas stream with certain media, or let's say liquid in this case, please have a look at the video and see what's happening in there. And when I'm now transferring to this glass of water, which is actual standard tap water, and I take the straw and I bubble inside, then it's actually very much the same what's happening in here. Or is that not true? So let's think about it a bit. This water, tap water as said, is of a temperature of roughly 15 degrees Celsius. The breath I'm bringing inside via the straw has a temperature of roughly 37 degrees. And my breath is what? My breath is certainly nitrogen, it's oxygen, it's CO2, and it's water. So what is happening when I bubble inside? Let's imagine this bubble existing in the water itself. What is the bubble doing? Or what is happening on the, let's say, border of gas to liquid? The liquid here has 15 degrees. The vapor pressure inside the bubble figures, okay, I have a temperature of 37 degrees. So it's too much of water inside the bubble. So the water from my breath will condense inside this liquid, right? So what is happening is actually I'm doing the opposite of what's happening here, because I'm decreasing the amount of water in the carrier gas stream by blowing into this water, right? And furthermore, this is, as said, the opposite of what I'm trying to do. So I need to be aware about certain parameters. First, about my carrier gas stream, so the input I'm doing into this system, and I would need to be aware about my medium that I have in here. So, and these parameters are actually pressure in general, it's temperature, it's certainly the medium I'm talking about. If I would like to enrich with water, I need to be aware about, let's say, the condensation or evaporation energy of water. If you would like to professionalize that approach and really go ahead with a scientific approach on this, what you would need to know is the Clausius-Clapeyron equation. This equation talks or takes into account a certain starting temperature, a certain starting pressure, and is taking into account the evaporation energy. And with this you can estimate, or let's say calculate, the pressure, the vapor pressure at a given temperature. And this is exactly what you need to know when talking about something like this here. So for you at home, you would like to play around with this equation and, let's say, simulate or figure what is happening in this glass here. So I hope I could bring a little bit closer the idea of a process vessel like this one with a simple example like that. So I would certainly be happy if you would approach us with your further questions on that, but We would certainly continue this series in one of our next videos, and I would like to welcome you there as well. So far, so good. Stay healthy and see you in one of our next videos.